The sum of 8 one-digit positive integers is 68. If 7 of these integers are equal, determine the other integer. So we have 7 equal integers, so I'll call them all x, and there's 7 of them. And then you have another one, which I'll call y. And the sum of these 8 integers is 68. So this is the equation, and since we're only given one equation, and there's 2 variables, we sort of have to play trial and error here. So the integers are 1 digit, so obviously they're between 1 and 9. So let's try 9. Let's see what happens. So if x is 9, then let's solve for y. And when you solve this, you get y equals 5. Okay, so x equals 9 and y equals 5. That seems like a pretty decent solution, but let's see if there's any others. Let's try x equals 8. So that would be 7 times 8 plus y is 68. And when you solve this equation, you get y equals 12. The problem here is that 12 is not a one-digit number. And similarly, if you keep going down, x equals 7 and so on, the values of y actually would keep increasing. So you would never get a one-digit number. So the only solution is that, and I believe they're asking for the other integer, and that other integer is the y, which I have found to be equal to 5. The 5-digit positive integer 15ab9 is a perfect square for some digits a and b. What is the value of a plus b? Well, I don't know, so I have to estimate. This number is a perfect square. All right. Okay, so that means if you took the square root, it would be some integer. Now, obviously I don't know what a and b is, but let's see. Let's approximate. Let's say the number was 15009, and I take the square root. What would I get? With my calculator, I got 122.5. So it's in that vicinity. So then what I did was I took this 122.5, or I took 123, since we need an integer, and I squared it. And when I squared it, I got 15129. And that looks very similar to that. And therefore my AB is 1, 2, so therefore A is 1 and B is 2. And for some reason they want the value of A plus B. Well, that obviously would be 3. If B is not equal to 0, we define A heart B as AB minus A over B. For example, 3 heart 1 is 3 times 1 minus 3 over 1, which is 0. X is 4 heart 2 and Y is 2 heart 2. What is the value of X to the power of Y? So I guess we just use this definition right here, and here we go. So x is 4 heart y. So, 4 heart 2. So that is going to be, according to that definition, 4 times 2 minus 4 over 2, and that looks like 6. And then y is 2 heart 2. So again, using that formula, 2 times 2 minus 2 over 2, so that is 3. So then finally, this x to the power of y looks like 6 to the power of 3, and that is 216. The numbers 36, 27, 42, 32, 28, 31, 23, 17 are grouped in pairs so that the sum of each pair is the same. What is the pair? What is the number paired with 32? So they're paired in groups of 2. Yeah, so 36 plus 27, all of these numbers combined would basically be 4 pairs. So I'm going to add them all up and then divide by 4 to get the value of each pair. So when you add it all up, it's 236. And then when I divide 236 by 4, because there's 4 pairs, it's 59. So that means each individual pair has 2 numbers that add up to 59. So if I have some number paired with 32, let's say that number is x plus 32 will be 59. And that means that x is 27. So 27, this 27 is paired with this 32. And then similarly, other pairs that add up to 59. In the diagram, points B and C lie on AD and point E lies on CF. The measures of 4 angles are shown. What is the value of x plus y plus z? So this is what you call angle chasing. And let's do that. All right, where do you want to start first here? Well, this angle in here, that guy is going to be 180 minus 124. And that's 56? Yeah. So let's put that 56 in there. And then this angle in here would be 180 minus y and z. So 180 minus y minus z. So therefore this angle in here, that would be the complement or supplement, whatever the word is. So y plus z. Yeah, y plus z. And what are we trying to figure out? Oh, x plus y plus z. Okay, so I guess I'll just use this triangle now. All the angles in that triangle have to add up to 180. So x plus y plus z plus 56 have to add up to 180. And therefore x plus y plus z is 124. Okay, pretty interesting. In the diagram, the positive integer is hidden behind each star. The integer shown on each star is the product of the integers hidden behind the other 3 stars. What is the product of all 4 integers? Okay, so I don't know what the integers are behind, so I'll call A, B, C, and D. Those are the integers hidden behind the stars. So the 280 is basically B times C times D, right? The product of the integers hidden behind the other 3 stars. Okay, so this 168 is A times C times D, correct? And so on. You guys get the point. This is A times B times D, and this is A times B times C. So what do they want? They want the product of all 4 hidden integers. So basically they want me to find A times B times C times D. Okay. What I can do is I can multiply all these guys together. So B times C times D times A, C, D times A, B, D times A, B, C. And that is 280. Since this equals 280 and this equals 168 and so on. And that equals 105 and that equals 120. Like that. Okay, let's see where this leads us. These guys, if you carefully combine them, will give you it'll be A, B, C, D all to the power of 3. Or you can just write them in A to the power of 3, B to the power of 3, and so on. And this big long number is 592704000. So I guess to get A, B, C, D, you would take the cube root of that guy. So cube root of 592704000. And the cube root of that is the very nice whole number 840. And there you go. That's exactly what they wanted, A, B, C, D. In the diagram, the circle has a center O and a radius 6. Point A is outside the circle and points B and C are on the circle. So that AB is perpendicular to BO. AC is perpendicular to CO, and angle BAC is 50. What is the area of the shaded region? Well, the first thing, what should I do here? Just draw a line from A to O like that. And then these are right angles, right? Yeah. Well, that was 50 before I drew a line through it. So that means that's 25 and that's 25. Yeah, this diagram is symmetric. And therefore, you guys can figure out that would be 65. And this would be 65 because the sum of the angles of a triangle are 180. And these are 90 degrees right there. So that means this whole angle is 65 times 2, which I believe is 130. So to get the area of that, it would be a ratio like 130 over 360 times pi r squared. And I think that's it. So 130 over 360 pi, the radius is 6. And when you do this math, you get 13 pi. And that is indeed the correct answer. When 3 students, Al, Betty, Charlie, compete in a competition, there are 13 possible orders of finish, allowing for the possibility of ties. These possibilities are illustrated in the chart below. When 4 students, David, Aaron, Frank, and Greg, compete in a competition, how many possible orders of finish are there, allowing for the possibility of ties? Okay. Well, we have a few scenarios. We have, I'll just use A, B, C, D. This makes it easier. Let's just say the 4 students are A, B, C, D. We have this sort of the standard finish, first, second, third, fourth. Now, how do you do that? 4 possible ways of getting the first choice, then 3 possible ways of choosing the second person, then 2, then 1, and you have to multiply them. So it'd be 4 times 3 times 2 times 1, and that's 24. That one's pretty straightforward. Okay, another way of finishing is if you have all 4 people tied for first. So we have A, B, C, and D. And there's only one way of doing that. Okay, so that was pretty straightforward. Now things start to get a little complicated. Another scenario is you have 3 tied for first. So you have A, B, C like that, and then the next guy would be D, something like that. And there's 4 ways of doing that, right? You could have either A as second, or B as second, or C as second, or D as second. And this is the D as second example. Okay, 2 tied for first and 2 tied for second. That's the next scenario. Okay, this one, 2 tied for first. So for example, you have A and B that are tied for first, and then C and D tied for second. We got to figure out how many of these. Well, for A and B, you have 4 choices for the A and then 3 choices for the second guy, so that's 12, right? But AB would be the same as BA, so you got to divide that 12 by 2. So that gives me 6. So 6 ways of sort of figuring out the number of possibilities there. And then the next one, the CD. Let me think about this. I think that's when you choose A and B, the first 2, then there's nothing left except the next 2, and you just put them both in second place. So that's it. 6, I think, is the total. Yeah. So this is 6. I hope that's right. 1. And I think this one here. This one, you can also have 3 tied for 2. I knew there was something I was missing. If you have 3 tied for 2, second place, I should say, it's the same kind of story. You will also have another 4. So this actually is 8 total. Make sure I do this correctly. Okay, now the final scenario is 2 tied for first place. Okay, so that means you have, so for example, you have like A and B, and then you have, say, C, and then you have D. So for A and B, you have 4 times 3, which is 12, but then you have to divide that 12 by 2, because that could also have been BA, and BA and AB are the same thing. Or you can have 2 tied for second. And when you have 2 tied for second, wait, let me go back to this one here. I didn't think I finished this. 6 takes care of these guys, but then I have 2 choices remaining for that. So that 6 has to be multiplied by 2, which gives 12, and 12 is the total scenario for that. And then the D, the third place is just whoever's left over. And the 2 tied for 2 is the exact same calculation as what I did up there. So that's also 12. And then you can also have 2 tied for third place. And that's also the same calculation. So that 12, and that 12 gives 36. So the grand total would be this 24, that 1, this 8, this 6, and this 36. 24 plus 1 plus 8 plus 36 plus 6, and that is 75. In a geometric sequence with 5 terms, t1 through t5, each term is positive and t1 is greater than t2. If the sum of the first two terms is 15 over 2 and the sum of the squares of the first two terms is 153 over 4, what is the value of t5? Okay. Well, t1, t2, t3, t4, and t5. So we have ar squared, ar to the power 3, ar to the power 4. So those are the first 5 terms, and they told me that the first and the second term adds up to 15 over 2, and the sum of the squares of those guys would add up to 153 over 4. And this is also very important right here, that t1 is greater than t2. If that is the case, then that means our r is less than 1. And I'm assuming it's greater than 0, since each term is positive. Okay, yeah, so I'm correct in that assumption. Okay, so where do I go from here? That's the setup of the question. And I guess from here I have to figure it out on my own. So far I'm just written what the question gave me. Now it's my responsibility to figure this out. Okay, so well, we have two equations, two variables. So basically it becomes one of those questions where you got to figure out the value of each. Let me factor out an a here, 1 plus r, 15 over 2. And then let me factor out the a squared on this guy, so it becomes 1 plus r squared, 153 over 4. And then what I'll do, I'm just trying to figure out, you can do this in any way you want. I'm going to square both sides here. So a squared, 1 plus r all squared, and then 225 over 4, right, when you square that? And then I can combine this guy and this guy. If I divide them, I will get 1 plus r squared over 1 plus r squared. And the a squareds would cancel. And then you have 225 over 4 over 153 over 4. And this has only one variable. So that would allow me to solve for that one variable. Okay, I'm pretty sure I did that the right way. Okay, so let's expand. So this would be 1 plus 2r plus r squared. And this becomes, the 4's cancel, and this just becomes 225 over 153. And this is 1 over 1 plus r squared. So if you cross multiply, you're going to get 225 plus 225 r squared, 153 plus 306 r plus 153 r squared. And then let's put everything on one side. And when you do, you get 72 r squared minus 306 r plus 72 is equal to 0. And when you divide through, getting into lowest terms, it's 4r squared minus 17r plus 4. Okay, so we got a quadratic equation, and you can use a quadratic. There's nothing wrong with using a quadratic. If you can factor it, that's great. Either way, as long as you get the value for r. If you factor, let's see here, r 4 1/4. Or actually, interesting. How would you factor this? Let's see here. I think the way to factor this would be 4r and r, and then a 1 and a 4 minus minus. So that would give me roots of 4 1/4. Yeah. Well, since r is between 0 and 1, the only valid one is 1/4. Okay. So we got r, and then to get a, I can just sub it back into any one of these guys. So let me just sub it back into there. So a plus a over 4, if you use r equals a quarter, is 15 over 2. So 5a over 4 is 15 over 2. And therefore 10a is 60. And a is therefore equal to 6. And then finally, they want us to figure out T5. Okay, so T5 is right here. It's a R4. So a R4. We have a equal to 6. R is a quarter. And when you do this math, this turns out to be 6 over 256, or in lowest terms, 3 over 128. The diagram shows a rectangular picture frame ABCD made up of 8 identical trapezoids. The shaded region is where the picture goes. The length AB and the width AD of the frame are both positive integers. The area of each individual trapezoidal piece is a prime number. If the area of the shaded region is less than 2,000 square units, what is the maximum possible area of the shaded region? Let's label this first. Call that X. So therefore that's X, and the smaller segment Y. So that means this is Y, X, and so on. And the height of that trapezoid I'll draw here, and I'll just label those guys H. Okay. Now the formula for the area of a trapezoid is, well, according to the letters I designated, it would be X plus Y over 2 times H. And they're saying that's a prime number, so I'll just call it P for prime. And I'm just trying to create formulas. The area of the shaded region, since it's a rectangle, so it'd just be length times width. This is Y, by the way. So it would be Y times, let's see here. Looks to me like just 2y plus x. And that they're saying is less than 2,000. So that's a parameter, sort of. Okay. But I've got 3. Oh, boy. I actually got 4 variables in here. So I'm going to need at least one more. Well, technically, I need 2 more. How can I get that? Well, I can compare these sides here. This side minus this side here is going to be the leftovers, which is the 2h. So that means 2x plus y minus that 2y plus x, that is equal to 2h, correct? So that means this is going to be x minus y is 2h. Okay. So this equation, this equation, and this isn't really an equation, that's more of a sort of a parameter. So let me just work with these two guys here and see what I do. I don't think I'll be able to solve for actual values because there's not enough equations, because I've got x, y, h, and p. I've got 4 variables and only 2 equations, so we're going to have to do some manipulating here. Let's see. Okay, so from the second equation, we got x plus y over 2 times h is p, right? Some prime number. So let's just multiply through here by 4. And then if I do that, I'll get this 2h, and that'll be 4p, because there's a 2h here. That's why I wanted to get a 2h. And then since that's 2h, I can put that in there. I can sub it in there. 2h is x minus y, so let's sub it in. Okay. Okay. Now at this point, I've got to look at this. This is obviously an even number since it's multiplied by 4. But p is a prime number. But when you multiply by 4, that 4p would be even. So therefore, this and this both have to be even. That's the only way you're going to get an even. Is that right? Because I'm pretty sure. Wait, let me think about this. Even and even multiplied together obviously is even. But what if you had an even and an odd? But these two are in such a way, x plus y and x minus y are written in such a way that they have the same parity, meaning they're either both even or both odd, and you can test that with different numbers. So the only way for this to work is for them to be both even. So that's just looking at parity. And therefore, that 4p, the only way to break it up into even and even would be to put a 2p here and a 2 here. And that's it. That's the only way. Okay, so therefore, x plus y is 2p, and x minus y is 2. And if I solve this, this would be, if you add it, it becomes 2p plus 2. So therefore, x is p plus 1. And that's obviously very important. And then if we continue here, solve for y, you can just plug it back into either one of these guys. You can just put it in there, for example, or no, that doesn't have a y. I'd have to put it into here. So y would be 2p minus x, which end up being 2p minus p minus 1. So y would be p minus 1. Okay, so now let's go back and look at that guy there, which is the area of the shaded region, area of shaded region, AS. So anything else? I've calculated x and y. I should probably calculate h, right? Because that's also needed. So I'll use that formula. So 2h would be x, which is p plus 1, minus y, p plus 1 when I subtract it. So 2h would be just 2. So h is 1? Hold on. Yeah, that's correct. Interesting. Okay. So now let's see what happens with AH. So this is AH. So that's going to be y times 2y plus x, correct? And that is less than 2,000. Okay. So we're gonna put in all these values in terms of p. So that's p minus 1 times 2 times p minus 1. So 2p minus 2 plus x, which is p plus 1. So interestingly, h is not even required the way I did it. So this is p minus 1 times 3p minus 1 is less than 2,000. Okay. So at this point, I think you could probably do a quadratic. Yeah, that would be perfectly valid. Or you can just start subbing in values that are primes. That'd probably be a little bit quicker. Like for example, if you try p equals 23 and you sub that into there, just for this part, you would get the AS, area of the shaded region, to be 1496. And if you try the next prime number, which is 29, the area of the shaded region would become 2408. So since that's obviously greater than 2000, this is the largest you can make it under the parameters.